Jupiter is not what you think it is. Almost everything you've been told about this giant world, everything you learned in school, everything you assumed from telescope images, is wrong. Jupiter isn't just a swirling ball of colorful gas. Beneath those iconic clouds lies a reality far stranger, far more violent, and far more unpredictable than anyone imagined. What scientists have uncovered inside Jupiter doesn't rewrite a chapter, it rewrites the entire story of planetary physics. For an entire generation, Jupiter was introduced as something simple, a massive gas giant. Nothing more than swirling clouds, colorful storms, and endless atmosphere. Textbooks portrayed it as a planet without a true surface, a world made of nothing but hydrogen and helium drifting in majestic patterns. But that version of Jupiter, the one printed in diagrams and taught in classrooms, was never the full story. In fact, it wasn't even close. The truth is that Jupiter is a planet humanity has misunderstood since the moment we first saw it through a telescope. Everything about it, its size, its weight, its composition, its history, defies the categories we try to place it in. And the deeper scientists look, the more Jupiter refuses to behave like the gas planet we once believed it to be. To understand why, we have to go back to the earliest images ever captured of Jupiter. The first close-up photo, taken by NASA's Pioneer 11 in 1974, showed dramatic bands wrapped around the planet like painted brushstrokes. It was beautiful, mysterious, but completely misleading, because while those clouds are iconic, they hide everything that actually matters. 5 years later, Voyager 1 approached Jupiter and sent back the first moving pictures, time-lapse footage of storms dancing across its atmosphere. Millions watched in awe, convinced they were witnessing the true nature of the planet. But those images raised far more questions than answers. What were those storms made of? How deep did they go? And why was Jupiter so impossibly large? Size, after all, is the key to this puzzle. Jupiter isn't just big, it dominates the solar system. More massive than every other planet combined, it could swallow 1,000 Earths without a trace. If Earth were the size of a grape, Jupiter would be a full basketball. And with that size comes gravity. Gravity strong enough to reshape entire worlds, to drag comets out of their orbits, even to protect the inner solar system from deadly impacts. But gravity also reveals something deeper. A planet this large shouldn't just be a cloud. It shouldn't even be mostly gas. Theories about its formation have changed dramatically over the years. One idea suggests Jupiter began as a rocky world that grew massive enough to pull in enormous amounts of surrounding gas. Another stranger idea imagines Jupiter forming almost like a failed star, collapsing from a separate cloud before being captured by the sun. Both theories can't be true, and for decades, neither could be proven wrong. Everything changed in 1994 when Jupiter was struck by the fragments of comet Shoemaker Levy 9. The impact ripped open its atmosphere and exposed its hidden interior for the first time in human history. For 6 days, NASA watched as fireballs, each more powerful than hundreds of millions of atomic bombs, exploded across the giant surface. And when the Galileo spacecraft arrived shortly after, flying directly through the debris, it discovered something that shattered everything we thought we knew. What was inside Jupiter shouldn't exist. Not in a gas giant. Not anywhere. What Galileo found would force scientists to rewrite Jupiter's identity from the inside out. When the Galileo spacecraft plunged into Jupiter's atmosphere in 1995, scientists expected turbulence, storms, and clouds, nothing more. But what they found instead was a world far stranger than the elegant bands seen through telescopes. Galileo entered the upper layers of the atmosphere expecting to encounter water vapor, lightning storms, and dense clouds. Instead, it found something unsettling: dryness, an absence of water where water should have been abundant. And beneath that dryness, a temperature and pressure profile that defied every prediction. Something was wrong with Jupiter, or rather, something was wrong with our understanding of it. As Galileo descended, it kept transmitting data that scientists couldn't explain. The atmosphere wasn't organized the way they expected. The chemistry didn't match any model. The structure of the cloud layers seemed incomplete, as if the probe had slipped into a pocket of Jupiter that didn't conform to the rules. But the real surprise came not from the atmosphere, but from what was lurking beneath it. For centuries, Jupiter had been labeled a gas planet, a world without a surface or solid structure. But Galileo's measurements revealed transitions in temperature, pressure, and density that only pointed in one direction. Jupiter was not a planet made of gas. It was a planet made of liquid. And not just any liquid. The deeper Galileo went, the more the atmosphere compressed. Hydrogen, the universe's lightest and most abundant element, was being squeezed by the overwhelming weight of Jupiter's mass. At a certain depth, the gas stopped behaving like a gas at all. It thickened, it condensed, it became fluid. Scientists had long theorized the existence of liquid hydrogen, but they expected it at depths far below what Galileo measured. Instead, Jupiter's transition from gas to liquid happened rapidly, far too quickly for traditional models. This wasn't a gas giant. This was a liquid world. Imagine an ocean so deep that it dwarfs Earth itself. An ocean not of water, but of hydrogen. An ocean tens of thousands of kilometers thick. But the deeper Galileo's data went, the stranger the story became. Because beneath the liquid hydrogen ocean lies something even more extraordinary. A layer of liquid metal. Under unimaginable pressure, millions of times stronger than Earth's atmosphere, hydrogen stops being hydrogen. It becomes metallic. Electrons break free from atoms. Fluid begins to conduct electricity like molten steel. This metallic hydrogen doesn't exist naturally anywhere on Earth. It can't. We don't have the pressure to create it. But inside Jupiter, metallic hydrogen isn't rare. It isn't a thin layer. It is the majority of the planet. 40,000 kilometers of liquid metal swirling in a rotating sphere the size of a small star. And that discovery changed everything. Suddenly, Jupiter's overwhelming magnetic field made sense. Its auroras, far more intense than Earth's, had a source. Its radiation belts, its storms, its heat emissions, all became explainable through the existence of this metallic core. But this created another problem. If Jupiter was a liquid metal planet, then what happened to the solid rocky core every theory predicted? What happened to the Earth-sized sphere of iron and rock that was supposed to lie at the center? Galileo's data pointed toward something shocking. The core wasn't missing. It was dissolving. Instead of a hard boundary between rock and liquid, Jupiter's core appeared fuzzy, stretched, diluted, mixed into the metallic hydrogen like ingredients blended into a cosmic soup. The deeper the probe's sensors modeled, the more chaotic the transition became. No clear edges, no solid ground, no place where core ends and liquid begins. This discovery broke every formation model scientists had relied on for decades. A planet as massive as Jupiter shouldn't have a mixed core unless something unimaginable happened in its past. A collision, a world-sized impact. Something enormous must have struck Jupiter early in its formation, churning its insides and scattering its structure. But that mystery, and what it means for the history of the solar system, is only the beginning. The deeper scientists looked into Jupiter, the clearer one truth became. This planet wasn't following the rules. For decades, researchers believed planets formed in predictable ways, solid core first, gas later. But Jupiter refuses to fit that pattern. And nowhere is this more obvious than in the strange region where its liquid metallic hydrogen meets what should have been a dense, rocky center. Instead of a solid structure, Juno's gravity measurements revealed something much stranger. A blurred, expanding core. Not a neat sphere, not a compact object, but a vast region, half the radius of Jupiter, where rock, metal, and liquid metal swirl together in a strange cosmic mixture. It's as if Jupiter's heart has been melted, stretched apart, and stirred into the surrounding metallic ocean. But how? The leading theory points to a catastrophic event in the early solar system, billions of years ago. Before the planets settled into their orbits, space was chaotic, filled with young worlds on unstable paths. One of those worlds, potentially 10 times the size of Earth, may have collided with Jupiter head-on. The impact would have been unthinkable, enough energy to vaporize iron, liquefy stone, and churn the entire interior of the planet. In that ancient moment, Jupiter's core didn't just crack, it dissolved, and the traces of that collision still exist today. The fuzzy, diluted center Juno continues to observe. But even after solving the mystery of Jupiter's core, the discoveries didn't stop. Scientists realized that this massive metallic ocean, tens of thousands of kilometers deep, acts like a generator on a scale we've never seen. As Jupiter spins, this liquid metal shears and twists, creating a magnetic field so powerful it dwarfs every other planet's. It traps radiation, shapes space, and unleashes auroras that extend far above the planet's poles. Those auroras, glowing like cosmic fire, are driven not by sunlight, but by Jupiter's internal engine. And then there's the Great Red Spot, a storm so enormous it could swallow Earth whole. Yet it's only a small surface feature compared to what lies beneath. Scientists now know that Jupiter's storms extend far below the clouds we see, hundreds, even thousands of kilometers into the planetary interior, feeding off rising heat and deep convection currents. Every new discovery points to the same conclusion. Jupiter isn't a simple gas giant. It isn't predictable. It isn't understood. It is a world of fluid metal, dissolved cores, impossible storms, and physics pushed to their very limits. And yet, the biggest surprises were still waiting, hidden deeper than any spacecraft could reach. To understand Jupiter is to confront a world that defies the boundaries of nature itself. Every layer beneath its cloud tops reveals something stranger, more extreme, more impossible than the last. And the deeper scientists try to model its interior, the more they realize that Jupiter is not just a planet. It is a laboratory for physics that does not exist anywhere else in the solar system. Let's start at the top. Jupiter's familiar cloud bands, the swirling stripes everyone recognizes, are not just atmospheric decoration. They are the visible skin of a global weather system unlike anything Earth has ever produced. Those clouds are made of ammonia crystals, water vapor, and complex chemical compounds sculpted into motion by powerful jet streams. Lightning flashes within them with energies hundreds of times stronger than the bolts we see on Earth. And towering storms, some larger than continents, rotate in deep circulating cells that plunge far below the surface. For centuries, humans believed those clouds extended for tens of thousands of kilometers. But the truth is far stranger. They are only about 50 kilometers deep, a thin, dazzling veil stretched across the planet's massive body. Beneath that veil lies Jupiter's true identity. As you descend below the clouds, the temperature begins to rise, pressure increases. The hydrogen that fills the atmosphere becomes denser and denser, compressing itself under Jupiter's immense gravity until it begins transitioning into a liquid. At around 1,000 kilometers below the cloud layer, the transformation is complete. The gas becomes an ocean, the largest ocean in the solar system, but not an ocean of water, an ocean of liquid hydrogen. And this ocean isn't calm. It churns with rising plumes of heat, descending currents, and storms so massive they influence the planet's magnetic field. The deeper you go, the thicker the liquid becomes, until the pressure reaches a point where hydrogen as we know it simply stops behaving like hydrogen. At over 1 million times Earth's atmospheric pressure, the electrons inside hydrogen atoms break free. They begin to flow throughout the liquid, and suddenly, hydrogen becomes something completely new: liquid metal. This metallic hydrogen region is colossal, tens of thousands of kilometers thick, and it behaves like a global sea of molten electricity. As Jupiter rotates, this metallic ocean moves with extraordinary speed. It stretches, twists, and spirals around the planet, generating a magnetic field so powerful it dwarfs that of every other planet in the solar system. Jupiter's magnetic field is 14 times stronger than Earth's. Its magnetosphere extends millions of kilometers into space, so large it would appear bigger than the moon if our eyes could see magnetic fields. And the radiation trapped within it is so intense that any unshielded spacecraft entering it would be destroyed in hours. This magnetosphere is the reason Jupiter shines with its own kind of light. Its auroras, massive glowing rings around its poles, are not produced by sunlight. They are the result of the planet's magnetic engine ripping charged particles out of space and hurling them into its atmosphere at extreme speeds. Beneath the metallic hydrogen layer lies the greatest mystery of all: Jupiter's core. For decades, scientists believed Jupiter contained a solid Earth-sized sphere made of rock and iron. But the Juno mission shattered that belief entirely. Instead of a compact core, Juno's measurements revealed something unexpected: a blurred, dissolved, chaotic center that stretches across half the planet's radius. It is not solid. It is not liquid. It is not stable. It is a mixture of rock, metal, and metallic hydrogen, swirled together like ingredients suspended in a giant cosmic storm. The best explanation scientists have is that Jupiter once endured a colossal collision in its infancy, a massive impact with a world possibly 10 times the size of Earth. The energy from that impact shredded Jupiter's core, scattering its materials into the surrounding metallic hydrogen and preventing them from ever settling again. But even today, no one fully understands how Jupiter formed. Some theories claim it began as a rocky world that grew large enough to pull in surrounding gas. Others suggest Jupiter formed almost like a star, collapsing from its own cloud of gas before being captured by the sun's gravity. The truth is unsettling. We don't know how Jupiter came to be, and until we fully understand it, we cannot claim to understand how any planet truly forms. Jupiter is not a gas giant. It is not a predictable world. It is a planet of liquid metal, dissolved cores, impossible pressures, and physics pushed to the absolute breaking point. And the most astonishing mysteries still lie ahead. For centuries, Jupiter has dominated our night sky as a familiar giant, a swirling marble of color drifting calmly beyond the asteroid belt. But everything we've uncovered about this world in the past few decades tells a very different story. Jupiter isn't stable. It isn't simple. It isn't even something we can fully categorize. It is a planet built on extremes. Extremes of pressure, heat, magnetism, and motion that push our scientific models to their limits. Think about what exists beneath those iconic clouds. a layer of storms deeper than our entire atmosphere, an ocean of liquid hydrogen thousands of kilometers thick, a sea of metallic hydrogen stretching across the majority of the planet, a material so exotic it cannot exist naturally anywhere on Earth. And at the center of it all, a core that isn't even a core, but a swirling, expanding mixture of rock and liquid metal blurred together in a way that defies every rule of planetary formation. Jupiter is not what you think it is, and the more we learn, the less we understand. One of the greatest surprises came when NASA's Juno spacecraft began measuring Jupiter's gravitational field. Each orbit revealed strange asymmetries deep inside the planet, patterns that shouldn't exist if Jupiter had a stable, solid center. Instead, these measurements painted a picture of a world whose interior is constantly shifting, mixing, and evolving. Imagine a heart made of molten metal and dust, stretched and reshaped by pressure so immense it dissolves matter into states that shouldn't exist. That is Jupiter, and if that wasn't enough, the planet's magnetic field is so intense that it creates radiation belts capable of destroying spacecraft. Its auroras, powered not by sunlight, but by internal electrical currents, are some of the most powerful light displays in the solar system. They never stop. They never fade. They are the visible heartbeat of a planet still roaring with energy billions of years after its birth. But perhaps the biggest mystery of all is how Jupiter formed in the first place. Was it a rocky world that grew enormous and captured its atmosphere? Was it a failed star born from its own collapsing cloud of gas? Did a catastrophic collision scramble its core and set it on a path we still don't fully understand? No model, no simulation has been able to explain everything we observe. And that's why Jupiter matters. Because it may be the key to understanding not just our solar system, but every solar system. The processes that shaped Jupiter may be universal. The physics that forge liquid metal oceans, blurred cores, and magnetic engines may define the evolution of countless worlds across our galaxy. Jupiter is not just a planet. It is a question science still hasn't answered. And maybe that's why we keep going back. Why missions like Juno are rewriting textbooks. Why astronomers still stare at that swirling giant and try to imagine the forces inside it. Because Jupiter shows us that even the worlds we think we know can surprise us, and that the universe is far stranger and far more extraordinary than anything we were taught. If this journey into Jupiter's impossible interior changed the way you see our solar system, let me know in the comments. What do you think lies at the heart of this mysterious world? Share your theory below. I read every comment. Like the video if it opened your eyes to Jupiter's real nature. Subscribe so you don't miss the next chapter in our exploration of the universe.